Hello everyone, my name is Liana Lixandru and today we will be looking together at an example of how to use Micronaut and Oracle functions together to control the starting, stopping and the status of our compute instances in Oracle Cloud. So to start off, let me show you what the function looks like. So we will be looking at the command that I used to create this function. So this would be using the Micronaut command line interface mn create app with the features Oracle Functions, Oracle Cloud SDK and GraalVM, because we will be also trying to build a native image of this function to run it in Oracle Cloud. And then we give it a package name. The build environment is Gradle, the language is Java, and we're using JDK 11. So by running this command, we will be creating our application. Now, once the application is created, there are some stuff that we need to do. And first of all is we need to replace the controller and we need to create an instance data class for our instance information. So if we look at our instance data, you see that we are importing some packages from Oracle, right? So in order to be able to use those packages, we would be going to build.gradle and adding as a dependency for implementation com Oracle OCI SDK, and then the package called OCI Java SDK core. So by adding this to build.gradle, we are able to use all the classes from the core package. Now, what else do we need to do? We need to, for the tasks, right? So we will need to basically build a Docker container of our function in order to be able to add it to functions in Oracle Cloud. So in order to do that, so you will see that when you first create your application, you would need to fill in here the name of your container repository URL, your tenancy, as well as your repository. So as you can see, I'm putting mine on the Frankfurt container repository, my tenancy namespace, and then I am putting everything in a repository called Liana Lixandru /function samples. You see, I've done the same thing for Docker build native, and here the project name has a /native at the end, so we can differentiate it from the function that was not built using native image from GraalVM. Right, so after we've done this, let's look at the code. So first of all, in instance data, we are importing instance lifecycle state, and we are creating our class where we will be basically returning the availability domain, the compartment OCID, the display name, the lifecycle state, which is the one that interests us, of course, in this use case, the OCID, the region, and the time that our instance was created. So as you can see, we are returning here everything, right? So we can use those when we create our API. Next, let's look at the controller. So in the controller, we are importing some more packages from the Oracle SDK, which is the compute client from the core package, the instance model, get instance request, so we can get the instance data, the status of our instance action request and response, so we can actually perform actions on the instance, like starting and stopping them. And then, of course, we will be using get and post for our API, right? And then we are also importing the statuses running and stop, so we can show those. Right, so our controller has the base URL of /compute. And then we are creating a new compute client. As you can see, we don't need to do the login step because this is handled by the code. But, otherwise we would have to create basically a resource principal authentication. But in our case, we don't need to do that. So then our APIs, our endpoints, are get status for an OCID, which would be the OCID of our instance. And then for post, we can start an instance. And in this case, right, so let's look at the functions. So the status one returns a new instance data. And we can see here the get instance function defined. So we are getting an instance by its OCID and returning it. So we're using the compute client to connect and getting the instance data. Then our next endpoint is start with an OCID. This one is of type post. And here we are getting the instance OCID. And if its lifecycle state is stopped, we can go ahead and start it. Otherwise, we log that the instance was not in the correct state to start because it was already started or terminated or any other state that is not stopped. Then we do the same thing for stopping an instance, right? We check if the lifecycle state is running, and if it is, we are stopping the instance. And this is the function that handles the instance actions for start and stop, right? So we tell it the OCID, the action, and then we run it on the using the compute client. So that's pretty much it for this. Now you will need to have Docker installed and started. And what we need to do is we need to log in to Docker with our container repository. So in order to do that, we would need to go into OCI, into our profile, and create a new authentication token, which you can get in here, right? When you click on generate token, you will be given a token that you would need to copy and save in a safe spot, and that will be the token that you'd use to log into Docker. So the command, I'll just show it to you because I'm already logged in, is docker login -u and then your username. If you're using Identity Cloud Service, it is tenancy namespace / Oracle Identity Cloud Service / your username, and then the repository location, which ours is on Frankfurt. If you don't use Oracle Identity Cloud Service, you can remove this annotation from between the slashes here, Identity Cloud Service, right? So once we do this, and we use our password as our password, the authentication token that we generated. Once we do this, we can go ahead and push our container to the repository by using Gradle. So we do Gradle Amelie Docker push. And this will push our container to the repository. So let's run it. And in the same way, we will do it if we want to create a native image. We will do Docker push native. However, I'm not going to do the build on my personal computer because creating a native image requires a lot of heap space for the Java virtual machine. And so I will be doing this on a compute instance on Oracle Cloud, where I've already installed GraalVM. And I have installed the native image package, which needs to be installed separately. And there we can just do Docker push native using the containers. So there we go. We did it in 41 seconds. So that was pretty quick. And now we need to go to Oracle Cloud and configure the function here. So first of all, you will need to check that you've got a dynamic group in identity and security that is basically using as a matching rule all the functions in your compartment. So as you can see, my matching rule here is all resource types of type Oracle functions in the compartment ID that is the OCID of my compartment where I plan on deploying these functions and running them. Once you have created this, you will also need to add some policies, right? So the policies can be at compartment level, and this is the policy. So we will allow our dynamic group to manage functions family, to read metrics, to use the virtual network, to manage logging. And then we also need to allow our dynamic group to manage instances because we want to do some actions on instances, right? And very important, because we are planning on using this as an API, so over HTTP, we will be using at the end an API gateway to create a deployment for our function. So we can call it So in order to do that, we need to allow API gateway access to the functions in our compartment. So any user to use functions family in compartment, my compartment name, where the user is API gateway and the compartment ID is the compartment that I'm using, right? Now, in order to add our functions, we will go to Applications in Functions. And we will need to create a new application if we don't have one already. So an application can store a collection of functions. So in order to create application, we click on Create Application here, and we need to give it a name, a subnet, a virtual cloud network, and a subnet. So we will be using the function application that I already have created. And in here, you've got a very nice part of getting started where you can actually see how you can set it up locally. But what interests us is the functions part, right? So after we have pushed our Docker container to the registry, we need to create a function. So in order to do that, we would click here on Create Function, and we need to give it a name and then to tell it which image to use from which repository. So our repository is Micronaut computing function samples, and then it loads all the images in there, right? And then we need to tell it the memory to use. So for this example, we would be using 512 megabytes, and the time what we can leave as 30 seconds. So I can show you the same here in the function that I already created, because that's all there is to do. So if we go on Edit, we can see that the name is Micronaut Compute, the repository is the one that I've showed you before, and the memory is 512. And I've put here the timeout to 120, but we can just set it to 30. I was just doing some tests. Right, so once this is done, we need to actually create the API gateway and create the deployment that will be calling this function. So in order to do that, we will go to Developer Services and Gateways under API Management. And in here, we can see all the API gateways that we have created. So I already have an API gateway created, but to create one, it's very easy. You just need to give it a name, the type, whether it's public or private, and of course, we're using a public one, the compartment where to create it in, and then specify a cloud network and a subnet on which it needs to run. And that is it. So when we have our API gateway created, we can go inside it and go to deployments and create our deployment. I will show you what the deployment looks like. So this is the one that we're using. So let's edit it and look at what it looks like. So this is basically the same page that you will get when you create a new deployment. You need to give it a name and a path prefix, and we are using the same as the base path of our controller, right? So our controller uses /compute, and this is what we've put in here as the path prefix, /compute. We leave everything else untouched, and we then go to routes. And in routes, in order to just simply tell it to route any path to the function, we put in for the path / and under brackets path star, and the method is any. Right here, you can choose get, post, put, delete, patch, head options, or any, and we have picked any. And then the type is Oracle Functions, and then we need to tell it which application and which function to use. So we're using functions demos and Micronaut Compute. And then once this has been created, we've got here an endpoint that we can use to call. So I've got this endpoint already put into Postman here. So we can look at what it looks like. So it's a get on our API gateway /compute. And then let's check for the status, right? So we're using /status /an OCID of an instance. And we click on send. At the first run, of course, it needs to properly start up the container. So this is why the first call, if you haven't called the function in a long time, takes a little bit more until the container is started up. Subsequent calls will be much faster. And there we go. We can see that our instance is called Micronaut demo, and it is in the lifecycle state stopped, right? And now, if we want to start this instance, we would do a post. We would go into headers and add the content type application JSON. And then the URL is /compute again, /start, and then the OCID of the instance. And we would click on send. And here you can see that the lifecycle state is starting. And we can also check if this is working properly by going into compute instances and checking if our instance is indeed starting. And here it is. The state is starting, right? So this has worked properly. Now, in order to create the native image, like I mentioned before, I am using a build machine that is running on Oracle Compute. So you can see it right here. I am connected to it via SSH to its IP. And then what I've done is I have installed GraalVM. I have installed native image. And then I've installed Docker and Git. I've uploaded my function code to a GitHub repository, and then I cloned it in here. And then I just logged in to the same repository using Docker login, and then run Gradle W Docker push native, right? And this, as you can see, it starts running the GraalVM native image and building a native image out of it. So here you can see the memory usage, right? And it took 3 minutes and 48 seconds to build my container. And then it publishes it to the same container repository. So if you want to create then a function using that, like I have created a function here just to see which one is native and which one isn't. I have created 2 different functions in my application. So my second one is calling the native image. And for the native image, what is very interesting is that you need, of course, way less memory to run it. So we don't need to put 512 megabytes. 128 are just fine because it uses way less resources and it also starts up faster. I hope you've enjoyed this guide. Thank you for watching and I'll see you the next time. Goodbye.